Civil Geo and Civil Engineering Department of Pranata University. Before we will begin our session, I would like to ask you to please turn your microphone off so we can begin this session Pranata University situation. Before we will begin our session, I would like to ask you to please turn your microphone off so we can begin this session Pranata University situation. Before we will begin our session, I would like to ask you to please turn your microphone off so we can begin this session Pranata University situation. Before we will begin our session. Thank you. University situation. I will open our webinar with opening prayer, which will be delivered by Eldisha.
Sure.
Okay, good afternoon for all of us. Thank you for the opportunity that given to me by the moderator to lead this prayer as a Christian. Let us pray in the name of the Father, and of the Son, and of the Holy Spirit. Amen. God Almighty Father, we thank you for everything that you have given to us during the day. Especially for today, we can join this webinar together with good condition and healthy body. Now we will start our webinar. Please bless us, please bless all the participants, all the committee, and especially for the speaker. Therefore, we can start and finish our activities well. God, give us your spirit so that we can get something new, useful knowledge, and can be implemented in our daily life. Amen. We bless your name now and forever. Amen. In the name of the Father, and of the Son, and of the Holy Spirit. Amen.
Thank you, Eldisha, for deliver the opening prayer. So I will introduce myself first. My name is Gabriel. I am a lecturer from Unika Soegijapranata University, Civil Engineering Department. I will tell to all of you that this webinar will be presented by our honored speaker, Mr. Hank Miller, as a senior water resources engineer. Before we begin this session, I will tell about the rules in advance in multilingual, Indonesian and English. First, attendees is not allowed to open or unmute their microphone during the presentation. Yang pertama, para peserta diharapkan untuk tidak membuka atau mengaktifkan mikrofon pada saat presentasi. Second, for any question, please write in the comment section, or you can give live feedback by unmute your microphone, and then when it has been noticed, you can begin to ask question by turn on your microphone and speak. Yang kedua, untuk pertanyaan teman-teman bisa langsung menulis di kolom komentar atau teman-teman bisa meng-unmute dan menyebutkan nama, dan setelah itu ketika saya sudah mengetahui siapa yang berbicara, teman-teman bisa langsung mengajukan pertanyaan secara live. Bisa lewat bahasa Indonesia, nanti akan saya terjemahkan. Okay, thank you very much for your attention. Now let's begin our session. Please welcome Mr. Hank Miller. Take your time.
Thank you so much. Thank you everyone for joining in. Firstly, I would like to ask, is everyone able to see my screen all right? Can you see the pointer moving?
Yes, it is clearly seen.
Perfect. So what kind of HEC-RAS work that you do there? Are you doing more flood studies, bridge replacements, dam failures, stream realignments, or all of the above? What's it that you do?
We usually use HEC-RAS for modeling surface runoff or flood prediction, Mr. Hank.
Mm-hmm. Okay, and which platform do you prefer? Are you using more AutoCAD, AutoCAD Civil 3D, MicroStation, ArcGIS, or all of the above?
Usually we combine the AutoCAD and ArcGIS.
Okay, and are you doing mostly 1D modeling with HEC-RAS, or you're starting to get into 2D modeling?
Actually, using HEC-RAS is something new for me and all of the attendees here, mostly.
Okay, got it. All right, so that's all I want to know. Now let's go ahead and start it. Now, what you're seeing on my computer screen is based upon technology that we have licensed from Autodesk. So it allows us to bring in AutoCAD drawings, Civil 3D drawings, microstation drawings, survey data, LiDAR data, point clouds, and other data. It also has a GIS built into it, so it can bring in GIS geospatial databases, GIS shapefiles, GIS elevation models, and other GIS data as well. But something that is interesting about the software is that it allows us to run HEC-RAS as a client-server application. It basically replaces the standard Army Corps Engineers HEC-RAS interface with the SCAD GIS interface. So let me show you how this operates. I'm going to start by pulling up one of my client's project data to demonstrate how to use a program to do a flood study. But to get started, as you're mostly using AutoCAD and GIS, firstly, I'm going to go ahead and pull up my AutoCAD drawing file. For that, I'll go over to File menu, choose Open. Let's navigate to our consulting work folder. Now, this project here is for the city of Akron, Ohio in the States. I'm going to go ahead and grab their AutoCAD drawing file that's in DWG format. Click on Open. It's coming up on my screen. Now, as soon as we have this drawing file loaded, next I'm going to bring in an aerial image in the background so that we can better see where everything is placed. From our Map Data Layers panel, I'm going to right-click and choose Add Base Map Layer. Now, this brings up our Add Base Map Layer data dialog box. Now, here you can see we have 16 different online mapping providers. We license the mapping content from these mapping providers directly from them. I am usually comfortable working with Hybrid Map by Google because this one gives a good mixture of aerial auto photos and labels for display. When I say OK to that, it's going to go ahead and throw a base map imagery in the background. Now, if you notice here, our CAD drawing is perfectly lining up with the base map imagery. That is because we already had the coordinate reference system assigned to the CAD drawing. So our software automatically reprojects on the fly. Down at the bottom, you can see the coordinate reference system that we are working with. However, if your CAD drawing doesn't have any projection associated, then in that case, you can go over to File menu, go to Map Coordinates Backstage page. Now, we list over 16,000 coordinate systems throughout the world. We have included all the coordinate reference systems that's been published and that we are aware of. But if you have a custom CRS, that may be a well-known text file or a shapefile projection, you can directly tie that to our database. You can even mark that as favorite so that it's easy for you to use that next time. Now, you guys are from Indonesia, so if I type in Indonesia here, so you can see it automatically filters out everything except Indonesia. You can see the different coordinate reference systems listed here. If you select any of those coordinate reference systems, on the right-hand side, it will show you a small preview window showing the extent of that projection. And later, you can click on Apply to Map View. In this case, as we already have a coordinate reference system assigned, so we're not going to click on Apply to Map View. Now, next, I'm going to go ahead and save the project. From File menu, I'll choose Save As. Let's navigate to our consulting folder. And let me go ahead and save it and name this as Flood Study. And click on Save. Now, down at the status bar, it says Flood Study has been saved successfully. Now, next thing I want to do is to create a 3D terrain model so that we can use that in our model. Now, HEC-RAS version 5 only supports 3 elevation file formats. Our software supports nearly every elevation terrain surface format, including elevation grids, TINs, and LiDAR. So our software will automatically convert your terrain surface into a format that HEC-RAS supports. So you do not need to worry about those issues. If you already have a terrain model, say in AutoCAD or even in Esri GIS elevation grid, you can directly utilize that. In this case, we're going to create our terrain model from these contours in our CAD drawing. It's very simple to do that. I will go over to Terrain menu and choose Generate Terrain command. Now, this brings up our Generate Terrain data dialog box. The first thing that you need to do is to define your terrain source. From the drop-down, you will notice that we can work with variety of data. You can generate your terrain from the CAD drawing, GIS data, land XML, LiDAR elevation data, point elevation data, and TIN surfaces. In this case, we're working with the CAD drawing. Next, we need to define the CAD layers for reading the elevations. I can click on this define button. You can see all the CAD layers listed here. In this case, we are working with just the GIS contour. So I'm going to check that layer on. If you want the software to read the elevation from multiple layers, you can select them as well. I'll say OK to that. Next, you can define your terrain grid limits. Here we will go with the elevation data source extents. That's the extents of our CAD drawing. Let's go ahead and save the terrain surface. Click on this browse button. Now, before we save it from the drop down, you will notice that we can save this elevation grid in any of the 4 industry standard formats. We're going to create a GeoTIFF elevation grid and name it as 3D terrain. Next, we can define at what grid resolution to create a terrain surface at. I'm going to manually enter a value of 3 feet. That's about a meter. It's going to generate about 7.7 million cells. Click on generate. Now the software is building a terrain surface for us. We are going to utilize the terrain surface for figuring out the extents of flooding and for 3D visualization. Once you have your terrain layer added, you can now switch to a 3D mode. You can grab this rotation tool to rotate the view around. As you rotate the view around, you will notice everything is in 3D now. You can right-click on your terrain layer and choose Zoom to Layer Extents so that you can see the extents of our loaded elevation terrain data. Guys, can you just mute your microphone? Pedro, yeah, Pedro has a microphone. Can you just mute your microphone, please? All right. Now you can see the extents of our loaded elevation terrain data. Now, we as civil engineers, we commonly run into a problem that we run out of elevation data. Now, what we have done, we have licensed the elevation data from NASA, and we have hosted that on Microsoft Azure Enterprise Cloud Computing Platform. So I'm going to backfill the elevation data beyond the extents of our loaded elevation terrain data. From our map data layers panel, I'm going to right-click and choose Add Elevation Layer. Now, if you have the elevation data saved locally on your computer hard drive or network drive, you can directly load that. You can see here the supported file formats that the software can read. You can bring any kind of elevation file format. You do not need to do any data conversion. Now, in this case, we're going to go with the online elevation data that is hosted on our cloud. I'm going to have the software use that. Now, one thing must be noted, that we provide a resolution of 10 meters that is confined within the borders of the United States and a resolution of 30 meters outside the borders of the United States. I'll say okay to that. And you will see that the software will start to seamlessly fill in other areas with this online elevation data. It has a vertical accuracy of 1 foot every 8 meters. Now, as you are GIS users as well, so I'm going to bring in some more or additional layers that Summit County GIS department provided us. From our map data layers panel, I'm going to right-click, and to bring in any kind of data, you just need to choose Add Layers. Now, before we bring in some of the GIS data here from the drop-down, you will notice the software can bring in 3D models, AutoCAD drawing files, GeoTIFF raster formats, both elevation and imagery, your gridded elevation format, LAN-XML format like for dense surfaces, LiDAR point clouds, microstation drawing files, PDF formats, which you can then georeference, your ASCII point data or the survey files. You can bring in your GIS shape files, GIS geospatial databases, vector file formats, and all files format. A lot of different data can be pulled in. The idea behind the software is that you should not have to do any data conversion. Software should simply be able to load the data and go. Now, in this case, let's navigate to our consulting work folder. And here I'm going to bring in some of the GIS data. So from the GIS shape files, I'm going to bring in our buildings and some land use roughness. Click on open, you will see them falling on the map view. Now, if I take this roughness layer now and expand it, you can see it automatically reads the legends showing the different roughness values. In fact, I can expand this data explorer and select any of those land use polygons on the map view. You can see this is completely GIS attributed. And we have a roughness value associated to each of those polygons. Later, we're going to map over the roughness data from these polygons to our cross sections. For now, I'm going to turn them off. You can also see those 3D structures. Now, these 3D structures are basically polygons representing the footprint of the building. We told the software to offset these polygons above the terrain a bit in order to make it look like these are 3D structures. Now, these buildings can be customized. If you want, you can click on that three-dot button. That's the Properties button for the buildings layer. It opens up your GIS Polygon Properties data dialog box. You have an option to change the color for the border stylization. You can change the color for your polygon fill. Now, these buildings are just the footprints, so they do not have any height or elevation attribute associated. So we can simply tell the software to offset them above the terrain, let's say 30 feet. We can extrude the walls and use base map imagery for the roofs. When I say OK to that, you will see how well those buildings have now been modified. The next thing I want to do is to define my river. I can go over to Input menu, go to River Reaches menu. We have multiple ways that we can define our river region. If you already have a river alignment available in your Autocad drawing file or as a shape file, you can directly assign that. If you have a survey file that contains the river geometry, you can import it. If you have your existing HEC-2 or HEC-RAS model, you can georeference the river reaches. In this case, we're going to use the Draw River Reaches command. If you notice, the software automatically puts me back into a 2D mode. It's going to create a curvilinear polyline. Click on that Draw button. If you notice and read down at the status bar, it says draw reach in an upstream to downstream direction. This river over here flows towards the north. So let's go ahead and start digitizing our river. I'm going to start over from here. You simply need to click and drag like I'm doing here. What's happening here in the background is that the software is built on top of AutoCAD. As I am digitizing that river, it's running a spline command in the background that is automatically curving that line for us. That gives our river kind of a more natural look. If you already have those alignments somewhere available in your AutoCAD drawing file or as a shape file, you do not need to spend a lot of time digitizing the river reach. You can simply assign those alignments as your HEC-RAS river reach, and that's going to save a lot of time. Now, what I'm doing here, I'm just looking at those contours and trying to figure out where the channel fallback is. Now, once you're done, you simply need to right-click and choose Done. Now, the software wants to know the name of the river and the reach. If you see on the map view, this is Cuyahoga River. I'm not a very good speller. It's good that I can see that on the map view. I can click on that new button. Let me type in the name. Let's call it Cuyahoga, give it a reach name as river, and click on Apply. Let me close the dialog box. If I zoom out and pan, now you can see the flow direction arrow on the map view. Now, let's say if you have defined your river in a wrong direction. You can right-click on the river alignment. It will open up your right-click context menu. And you can choose to reverse the river reach, and it will reverse your flow direction if in case you have drawn your river in a wrong direction. You can also choose Edit Vertices. You can see those small vertices here. I can grab any of those and move them around. I can click and add more vertices as well. Now, you do not need to do that. What I am really trying to point out here is that we have unlimited command over undo and redo. If I turn off the base map imagery, let's say that you have made any mistake in your model, or you want to take a different direction. You can go to this undo stack option, undo all the changes that you have made, and you will be back in your project. You can also press Ctrl+Z to undo the changes. Anyways, next thing I want to go ahead and define my cross sections. I can go to cross sections menu. Now, if you already have the cross sections or the alignments for the cross sections available on the map view, like from AutoCAD drawing file or as a shape file, you can directly assign those alignments as your HEC-RAS cross sections. If you have a survey file that contains the cross section geometry, you can import that. If you have your existing HEC-2 or HEC-RAS model, you can georeference the cross sections. You can also manually draw in the cross sections. However, I'm going to have the software automatically draw them in. So we're going to use the automated draw cross sections command. Now, the first thing that you need to do here is to define the downstream cross section devastation. You can tell the software how you want the cross section devastationing to be. In this case, the project is in US, so I'm stuck with Peter Miles. In this case, I want the cross section devastationing match the river change in feet. However, for your projects in Indonesia, you guys work with metric units, either meters or kilometers. When the software starts up, it automatically senses which country you are. And if you are outside of the US, it will automatically default to metric units. You can also define the spacing between the cross sections. Here, I will go with the default value of 500 feet. Next, you need to go to Extraction Data tab. You can first define the elevation source from which you want to extract the cross sections. Now, from the drop down, you will notice that the software allows you to extract the cross sections from CAD drawings, elevation grids, GIS contours, land XML data, terrain surfaces, and DIN surfaces. In this case, we're working with a CAD drawing. The software automatically remembers the appropriate CAD elevation layer, so you do not need to define that again. It remembers that from the previous edit. Now you can also specify the limits that the software should use in extracting the cross-section geometry from the elevation data. So here, we will limit our cross-sections to a maximum depth of 25 feet. And to figure out such kind of depth, I'm going to tell the software to extend the cross-sections to a maximum width of 3,000 feet. The software will then figure out how far it needs to extend the cross-sections to get 25 feet of depth. You do not have to count contours to try to balance the cross-sections. Software does all that for you. You can also tell the software where the channel banks are. You can define your bank stations based on your assumed channel width. You can define that based on your assumed channel depth. Or if you have the polylines or polygons with you that represent your overbanks, you can utilize them. You can simply click on that pick button. In this case, we have the polylines. Click on that pick button, zoom in a bit, and pick one of those alignments. To pick all others, simply right-click and choose Select Similar. It will select all others in the same layer. You can again right-click and choose Done. Now it says here we have 242 of those polylines being selected. Click on that Generate button, and the software is generating our cross-sections. Let's take a look what it did. If I close the dialog box, if I zoom out and pan, you will notice the software has automatically figured out how far it needs to extend the cross-sections to get 25 feet of depth. Now here at the wastewater treatment plant, the ground terrain is very flat, so that the cross-sections had to be extended out quite far. There is a lot of flooding that's occurring at that plant. In fact, if I zoom in a bit, you will notice that these two cross-sections are wanting to cross each other. But the software identified that and automatically bisected an intersection angle and ran these cross-sections parallel to each other. If in case you have the two cross-sections crossing each other, that accounts for the double conveyance and could be erroneous. Now to view the cross-section, you can simply go ahead and double-click on the cross-section. It opens up our cross-section data dialog box. Here you can see your cross-section geometry, the channel tallweg, your bank stations. As you scroll through your geometry table, you will notice the highlighted rows representing your bank stations. You can see your bank stations down at the bottom as well. Initially, what the software does, it assigns the default manning values based on what's in the channel and the overbanks. Now here, it's using a default value of 0.032 for the channel and 0.045 for the overbanks. Now, these are just the default values. We're not going to use them. Later, we're going to map over the roughness from the shape file that we loaded. It's going to assign the mannings to your cross-sections based on the horizontal stationing rather than what's in the channel and the overbanks. Now, let's say that you want to go ahead and define a small flood wall on this left overbank. You can grab this pencil tool. It will put you in graphic edit mode. You can grab any of those ground shots and move them around. As you move the ground shots, the software automatically updates the table for you. You can also choose to add more ground points. You can grab this Add Ground Points tool from the Tools palette here. I want a ground shot, let's say one over here and one over here. I can go ahead and zoom in a bit and define that more accurately. Now, if you put in a structure like this in HEC-RAS, it will assume this is a divided flow. You will have a situation where it will show you the water within the channel and beyond that flood wall. So you will need to explicitly call it as a levee. You can grab this Add Levees tool from the Tools palette here. You can zoom in a bit and place a levee on the top of it. If you notice, the software automatically switches me to an appropriate data panel, that is levies data panel, and all the information has been automatically been defined. So you do not need to manually define that information. One more thing that I want to point out here is that if I maximize the plot, on the right over bank, you can see there is a kind of a dead swale where I don't see much flows. I may want to mark this area as ineffective. I can grab this Add Ineffective Flow Areas tool from the Tools palette. I simply need to click and drag. If I restore the plot, you will notice it again switches me to an appropriate data panel, that is ineffective flow areas, and the information for the right over bank, stationing, and the elevation is automatically being defined there. You may also want to mark this ineffective flow area as permanent. Simply check this box and we're all done here. Let me go ahead and close the dialog box. Now, Geo-HECRAS provides several GIS mapping functions that will help us map over GIS attribute data to the HEC-RAS model. And we may want to map over that land use roughness that we loaded. So let me turn that back on. Now, if I select any of those land use polygons on the map view and expand the data explorer, you know that there's a roughness value associated to each of those polygons. Now, from those polygons, we're going to map over the roughness data to our cross sections. To do that, from input menu, you can go to Manning's roughness menu and choose Assign Manning's data. The first thing that you need to do is to select all the cross sections to which you want to map over that roughness data to. Click on that Select All button. Under the Polygon Layer tab, now you will need to define the Manning's layer and the attribute you're looking to map over to your cross sections. However, the software is smart enough. It automatically selects the appropriate layer, and from that layer, it automatically figures out which attribute to use. You can also see it also figures out your maximum and the minimum roughness values from the shapefile. You simply need to click on OK. It says Manning's roughness data successfully assigned. Now, if I zoom in a bit, you will be able to see those sub-roughness areas as segments on the map view. You can see from this polygon, it had a value of 0.055 assigned to it. Now that value has been assigned to your cross sections and can be seen as a roughness segment on the map view highlighted in purple. You can even see the corresponding Manning's roughness values showing up on the map view. Now from this polygon, there was a Manning's of 0.045 associated. Now that value has now been mapped over to your cross sections and is highlighted in the yellow segment. So you can see those roughness values on the map view as well using the roughness segments. Now let me do one thing. Let me turn off the roughness layer. Let's take a look what it did. I can double click on the cross section. From the drop down, if I go back to the geometry data panel, you will notice that the default Manning values that the software was earlier utilizing are grayed out. They're gone. Now the software is using the Manning's values from the shapefile. You have the multiple sub-roughness areas assigned to your cross sections based on the horizontal stationing rather than what's in the channel and the overbanks. Now you also have an option to edit these sub-roughness areas. You can grab this graphic edit tool or the pencil tool. You can hover your cursor on the top of any of those lines. You can see that highlights it. If you click and drag, you can move it around. Once you release the mouse, it will snap to the nearest ground shot. And the geometry table for the horizontal roughness will be automatically being updated. If you're not happy with the changes and you want to go back, you have an undo option here as well. You can undo the changes and you will be back in your project and the table will be automatically updated or reset to default. Let me go ahead and close the dialog box. We can also map over other data to the HEC-RAS model. If I go to Assign Entities menu, we can assign channel banks, we can assign flow lengths, we can assign ineffective flow areas, we can assign conveyance obstructions, and we can assign levies. I may want to assign these buildings as my conveyance obstructions. From Assign Entities menu, choose Assign Conveyance Obstructions. Simply select all the cross sections to which you want to map over those buildings as conveyance obstructions to. I'll click on that Select All button. Now you have an option to assign those conveyance obstructions from polylines, or you can assign those buildings as conveyance obstructions from polygons. In this case, we have the polygons. I can click on that pick button. I can pick one of those polygons on the map view. To pick all others in the same layer, right click and choose select similar. It will select all others in the same layer. You can see all of the building polygons glowing on the map view. You can right click again and choose none. Now here we have 352 of those polygons being selected. For the elevation assignment to those conveyance obstruction, we're going to assign the maximum cross-section elevation. However, if you have the polygons, if they have attributes like elevation or height associated, you can utilize that as well. I'll say okay to that. It says conveyance obstructions have been assigned. Now let me do one thing. Let me turn off my buildings layer and let me turn on my base mappometry back on. Let's take a look at those cross sections in 3D. I can switch to a 3D mode. Let me zoom in a bit here. And you will notice why I would mark this area as ineffective. You can see there is kind of a dead swale. If the water goes in that area, it will not be conveyed downstream. It will be stagnant over there, swirling with zero velocity associated to it. So that's why that area needs to be modeled as ineffective. On the other side of this cross-section, you can see the conveyance obstruction being mapped over to your cross-section. However, there's a problem here. If you notice, there's a small extension to this building that I was previously unaware of. What I can do, I can double-click on the cross-section. From the cross-section data dialog box, I can grab this Add Conveyance Obstruction tool from the Tools palette. Once you click on that, now you can click and drag and draw that extension to it. HEC-RAS doesn't like this overlapping. To fix that, click on that Fix Overlapping button, and it does the trick for us. Let me go ahead and close the dialog box. On the map view, you can see that extension being added. Now, Geo-HECRAS, it's a complete data wrapper to HEC-RAS, so it supports all aspects of HEC modeling. So you can define your roadway crossings, like bridges and culverts. You can define your 2D models, including hybrid models that have both 1D and 2D components. You can also define your lateral structures, such as flood walls, levees, and levee failures. You can define your inline structures, such as dams, spillways, and dam failures. You can define your storage areas like inline lakes, reservoirs, detention ponds, and off-channel storage areas. If I go over to Analysis menu, we can model both steady flow and unsteady flow models. We can also do the steady flow calibration or compute scour at bridges. Now we're almost ready to run the model. We just need to define our boundary condition. In this case, we're going to run this model in steady state. From Input menu, I'll go to Steady Flow Data. This opens up my Steady Flow Data editor. I'll go to the Flow Data tab. Let's say we have 3 different profiles for 3 different return periods. Let's say for a 25-year, 50-year, and then 100-year storm. We need to now define the corresponding discharges. Now for 25-year, let's say we have a discharge of 8,000 CFS, that is cubic feet per second. However, there in Indonesia, you work with cubic meter per second. So we can work with both the units. For 50-year, I'll set that to 12,000. For 100-year, I'll set that to 16,000. Next, we need to define the downstream boundary condition. And here, in this case, I'm going to set that to normal depth. And HEC-RAS will compute the starting water surface elevation based on the defined energy slope. Now, what you can do is measure the water surface elevation at 2 points near the downstream end of the river to approximate that slope. However, many times you cannot do that, since that might be someone's property you do not have access to, or you do not have the engineering budget to measure it. Whereas in our software, you can click on the Scalp button. The software will automatically compute an approximate energy slope by looking at the channel bed bottom slope. Software will run various trend lines upstream from the downstream boundary for up to 1 kilometer, and then use best fit line algorithm to estimate what the energy slope is. If you already know what the slope is, maybe you have computed that already on the field, you can type that in here. I'll have the software calculate that for you. I'll say okay to that. Now we are ready to run the model. I can go over to Analysis menu and click on that small running person, Compute Study. It's going to go ahead and run our HEC-RAS simulation. As the HEC-RAS simulation has completed, let me go ahead and close the dialog box. Next, we can take a look at the results. You simply need to go to Results menu. Let's take a look at the results for this cross-section here. I can select that cross-section on the map view and then go to cross-sections. The end results that you will get would be directly from HEC-RAS. We are a complete data wrap of HEC-RAS. Let me go ahead and close the dialog box. You can take a look at the other results like the profile plot showing you the longitudinal profile of your model. You can also take a look at your rating curve. You can look at your stage and flow hydrographs for your unsteady flow models, or the detailed output table for each of those cross sections or any hydraulic structures in your model. You can also take a look at your summary output table. Now, these are the standard HEC-RAS output tables. So you do not need to worry about the accuracy of the results. So let me go ahead and close that. Now, if you want, as your CAD users, you have an option to export these cross-section plots out to AutoCAD. If you click on the drop-down where it says cross-sections, and you can choose Export Cross-Sections to CAD. So let's go ahead and export our cross-sections to AutoCAD. Now here, you can also have the software include the analysis results. So here I will have the software include the results for my 100-year water surface profile. I'm going to have the software export out the water surface, energy grade line, and critical depth. I can go ahead and save the file, click on that browse button. I can navigate to my consulting folder, and let me go ahead and rename this to Access Plots. Now from the drop down, you will notice that we can save this file in any of the formats, starting from DGN format if you're a MicroStation user, DOST all the way to DWG 2018. Click on Save. Simply select all the cross sections to which you wanna export out to AutoCAD. Under the layer options, we have already provided the internal layer names. Like for the banks, we call them excess banks. There's cross-section banks. However, you have an option to rename them. Maybe your client has a different requirement. They want to call it something else. So you have an option to rename it as well. You can also change the line style, the color, and the fill. You can also have the software fill the ground area, fill structures, and fill water area. Click on OK. It's going to go ahead and write those cross sections out to AutoCAD. Now, if I go ahead and open up AutoCAD here, and let me open those cross section plots in AutoCAD. Just give it a moment. Now, if I zoom in a bit here, you will be able to see those cross-section plots in AutoCAD. And you can provide this to your clients. You can see the stationing, the elevation on the y-axis. You can see your multiple sub-roughness areas and your critical depth, your energy grade line, and your water surface as well with the fill. And let me go ahead and close that down. Now, next thing we would want to do is to create our flood map from the computed HEC-RAS results. From the results menu, we'll go to flood maps. Now here we will have the software create a flood map for our 100-year water surface profile. It's going to create a detailed intersection with your terrain model. Additionally, you can also tell the software to stylize the flood map. You can change the color for the border stylization. You can change the color for your fill. If you go to the flood contours, you can also have the software generate the base flood elevation contours and display contour labels on the map view. Now you can click on that OK button, and the software is now generating our flood surface based on our terrain model. There we have the flood map being generated. Now I can turn on the buildings layer. There you can see it. I can grab this rotation tool. I can rotate the view around. Now, if you want, you can expand the print and publish panel. You can take this out as a graphic file for your clients. You can take it out as a print file or even PDF. You can also record a video from it. Simply define the resolution for your video. set your zooming angle, set your inclination angle. Once you're happy with that, simply go ahead and hit that record button and save this as a Windows media file on your computer, and later hover your cursor on the top of this compass rose. This turns into a 3D navigator. You can go ahead and practically fly down the river and record an animated movie for your clients. We have a gaming technology built into the software, so you can use your joystick as well. Now, having all these pretty pictures is not worth anything unless we can share that with other programs. And key to this program is that it can interface with multiple of other softwares as well. So if I go over to input menu, go to export data, we can export the model out to normal HEC-RAS. So we have already created the HEC-RAS project in Geo-HECRAS, but if you want, you can export your HEC-RAS model, Geo-HECRAS model out to normal HEC-RAS. You have two options here. You can just export out the input data files, or you can archive your HEC-RAS project, include the output files and all the supported files like the terrain and the land cover. You can also include your base map imagery. Now I'm going to show you a shortcut how to open the same project in normal HEC-RAS. If I close this down, you simply need to right-click on your project tab and choose Open in HEC-RAS. It will take all those HEC-RAS model files and launch normal HEC-RAS on our screen. So this is the normal HEC-RAS interface. This is HEC-RAS version 5.0.7. Now you can go to that Geometry Data tab. It will load the same project in normal HEC-RAS as well. If I select any of those cross-section like the one that we were earlier working with, I can select that cross-section and choose Edit Cross-section. Now there you can see the same cross-section in HEC-RAS as well. Now it also reads the results from the same project directory, so you do not need to run the analysis again. Let me go ahead and close that. That was just to show you. You can also export your HEC-RAS model out to AutoCAD. So let's take a look at that. I will choose Export HEC-RAS to CAD. Let's go ahead and save the file first. I can click on that Browse button. And I've already created a folder named Exported CAD. I will save it right there. Now you can tell the software what HEC-RAS input and the output data you would like to export out. Like from the HEC-RAS inputs, you can include your river reach, the flow direction arrow, river junction, if any. Under the cross-section, we give you two options. Either you export your cross-sections as 2D polylines or 3D polylines, that is the elevation points. You can also include your output results like the computed flood map and the base map imagery, either in high, medium, or low resolution. Click on Export. Now the software is writing the project out to AutoCAD. Now it has been exported out. Let me open up Autocad Civil 3D here and let me open the project. Now there you can see the same project in AutoCAD as well. Now what I'm going to do here, I'm going to go ahead and turn off some of the layers. I will turn off my base map imagery and the flood fill extents. Let me go ahead and close the dialog box. Now I can switch to a 3D mode. If you zoom in a bit here, and hover your cursor on the top of any of those polylines, like this cross section, you can see this is a 3D polyline. In fact, all of them are the 3D polylines. And let me go ahead and minimize that. You can also export your project out as Esri GIS shape files, or you can export your HEC-RAS model to Google Earth. Now, what I'm really interested in showing you is the exported model in Google Earth. Now, when you need to present your results to the clients who are not so tech savvy, like they don't understand AutoCAD, HEC-RAS, or GIS, you can simply provide them this KMZ file that's a normal KML file. It's going to zip all those HEC-RAS input and output data into a single file. Now, here you can define the HEC-RAS input and the output here for the cross-section results in the computed flood map. Here, I will go with the default settings and click on Export. As I am running a free version of Google Earth, it will automatically launch that on our machine, and it will take us to that project location. Now there, you will be able to see the same project that we just created in Geo-HECRAS in Google Earth. your HEC-RAS model is seamlessly being shared with Google Earth as well. You can see all the elements here, like your river reach, your cross sections, BFE contours, and the flood map. If you want to take a look at any of the elements like this cross section here, you can click on it. It will show you a graphical plot with all the attributes like the river station plan, profile, water surface elevation, what's the corresponding discharge, top breadth computed velocity, maximum channel depth, and minimum channel elevation. And you can provide this to your clients and they will still be able to see the results. Let me go ahead and close that down. You can even grab the small person on the top over here and simply drop him in the flood zone. Now there you can see your model in Google Earth. Now, when you show your clients this kind of output, they will think that you might have spent hours and hours in creating such project. You do not need to tell them that you made that happen just by a single click, right? So let me go ahead and close that down. All right, guys, I think that should give you a good perspective about doing 1D modeling, 1D HEC-RAS modeling using Geo-HECRAS. Now, if you have any questions, please go ahead and post them in the comment section right there. Or if there is anything else that you would like to see, please feel free to ask me. There are a few of the...
Thank you.
Thank you,
Hank, for your presentation. So I've got a few questions that delivered to me by private chat. The first from Lisa. Lisa, can you open your microphone and ask the question directly? Elizabeth Pilistra.
Yeah, before Lisa jumps in, I have a question from Erland.
Okay.
Yeah, so let me so to everyone, the question was that he wants to ask. They were conducting some research about the flood modeling and simulation, but it has a limit to roadway crossings for finite element method analysis. So let me. The thing is that till 5.0.7, HEC-RAS used to use for 1D models finite difference method. Now with HEC-RAS 6.0 being out, now we have the finite volume method available for 6.0 as well, with some limitations where you cannot use the Priceman slot and you cannot use a modified pulse method. Those are the two limitations of using finite volume algorithm scheme for 1D models. So the finite volume algorithm scheme will be available for 1D models as well, with HEC-RAS 6.0 being out there in the market. And other than that, when it comes to limitation of roadway crossings, the limitation of the roadway crossings was with the 2D modeling, not with the 1D modeling. If you want, I can show you how we can model a roadway crossing in the same 1D project. There's no limitation to that. However, for the 2D models, till 5.0.7, there was a limitation that we cannot model for the pressurized or the overflow or in the 2D models. But with HEC-RAS 6.0 now that has been there is no limitation to that. You can model your roadway crossings in 2D models as well.
Okay, Mr. Hank, do we need to meshing or divide some parts of the river if we want to do finite element method analysis?
Can you come again? What analysis?
Finite element method analysis.
I'm not able to understand it. Can you come again? Can you recall the question?
Okay. So the question from Erland, he says that for finite element method analysis, can it be run for flood modeling? I want to ask that if we want to do finite element method analysis or FEMA, do we need to divide the river to some parts or meshing it to some parts?
Yeah, absolutely. You're talking about hybrid models. Yeah, you can do that as well. For the 2D models, it's already using the finite volume solution scheme. For the 1D models, if you want, you can use for 1D models as well. Because if I go to analysis menu and go to if I change this to unsteady state for now, this is steady state. If I change that to unsteady state, if I go to analysis menu and go to unsteady flow computation options, now here for both 1D and 2D flow options, you can change here. The 1D equation component solver, you can change it from here. For the 2D flow options, there are two methods for diffusion and the full momentum equation, but it's already using the 1D finite volume solution scheme. So you can, when having the interaction between 1D and the 2D models, you can use 1D finite solution scheme, volume solution scheme for both the parts of the model, 1D as well as 2D.
Okay.
Yeah.
Thank you. The second question is from Rahma Fitri. She asked three questions. First, why do we need to mark the ineffective flow area? What is that for? What if we do, if we not define the ineffective flow area, since it has lots of them along the river, and it's quite hard to define them one by one?
Yeah, it's a very good question, and we have a very good fix for that. So firstly, when it comes to ineffective flow areas, you will need to define the ineffective flow areas in the cross sections that will contain water that is not being actively conveyed. Ineffective flow areas are often used to describe a portion of the cross section in which water will pond, but the velocity of the water in the downstream direction is close to zero. This water is included in the storage calculation and other weighted cross-section parameters, but it is not included as a part of the active flow area. When using the ineffective flow area, no additional weighted parameter is added to the active flow. Now, when it comes to where we will need to define that, you will need to define that where you have the roadway crossings for both the overbanks. Ineffective flow areas often occur near the roadway crossings where the water levels exceed the channel banks and when water cannot flow in the longitudinal direction along the overbanks due to the roadway fill. When this occurs, flow must contract to pass through the opening under the roadway, adding additional and often significant losses. However, if the roadway crossing overtops, flow becomes possible in the overbanks areas as well in the main channel. So in that case, ineffective flow area is triggered off when it has been overtopped. Now, when it comes to if you adding the ineffective flow area one by one, I know that that's going to be a tedious task for you to add that ineffective flow area one by one. So that's why when I was demonstrating the software, I told you there's an option to assign entities, to assign ineffective flow areas. For example, if there is a dead swale, like say over here at these three crossings, I will turn off the base maptometry. Let's say there's a dead swale here, or an ineffective flow area here in all the three cross sections. What I can do, I can go to map edit menu. We have almost 80% of GIS functionalities built in. I can choose draw polygons and I can draw a polygon, let's say for these, around these three cross sections. Now what I can do, I can assign this polygon as an effective flow area and it will assign the effective flow area to all the cross sections. For example, if I choose assign entities menu, I will choose assign ineffective flow areas. I have an option to select all the cross sections or pick the cross sections one by one. If I choose pick, I can grab all the three cross sections here by simply drawing a selection window. Right click and choose them. Now you can assign the ineffective flow area from polylines or from polygons. I'm going to choose polygons. I can click on that pick button. I have drawn this polygon. I'll pick this polygon, right click and choose them. You can assign the elevations to it. You can go with the maximum cross-section elevation. If you want to mark this permanent, you can do that as well. I'll click on OK. Now, if I turn off the default drawing layer, you can see if I double click on the cross-section, the area over here is marked as ineffective right there. That way, you can assign the ineffective flow areas to multiple cross-sections at once without you having to do that one by one. Hope that answers your question.
Okay.
Okay, there's a question from Udi. How to do the calibration process? Yeah, we have a semi-automated process. If you already have the field values for the water surface elevation, then in that case, you can go to analysis menu and choose steady flow calibration. You will need to define your observed water surface elevations here. And based on that, it will calibrate the model and come up with the calibrated Manning values here. So once you define your observed values here, then you need to click on Analyze button. It will calibrate the model and come up with the right Manning value that should be assigned to the cross section to come up come up to a level where it is matching your field values. So calibrating the model is quite easy as compared to that of HEC-RAS because we have the semi-automated process. You can do that for all the 3 profiles if you want, or you can do that for just a single profile. Just the only thing that you need to have is the observed water surface elevation on the stages that you would get from the high flood marks. When mostly the flood event occurs, people mark the high flood areas on the walls, on the buildings, or the bridge piers. So once you get those kind of data from the field, then you can simply place that here and then analyze it, and it will calibrate the model by changing your Manning roughness values for each of the cross sections.
Okay, the next question is about flood delineation area. Can we calculate the area of influence of flood? Maybe she means that can we calculate how far the flood can impact the area around the river?
Yeah, absolutely. Like here for the 100-year profile, we had a discharge of 16,000 cubic feet per second assigned, and it created a maximum flood extent. So this is the maximum flood extent area.
Okay.
Yeah.
So we can predict predict the damage of the flood.
Absolutely. Then you can mitigate it as per how far the flood is extending out.
Okay, the next question from Tamal Fitri. She already has HEC-RAS software version 5.0.7. What is the difference between her software and this software?
Well, I think by now, me demonstrating it should have made it clear why it is different.
About the future, right?
I'll explain two of the differences here. Now, when it comes to HEC-RAS, you have to enter everything manually, but here everything is automated. Like we talked about assigning the ineffective flow areas, then you have to enter all the information there manually, like at what station, at what elevation you want your ineffective flow area to be. Here, you just need to click and draw. That means you're able to save at least 70% of your time just drawing the ineffective flow area. In the similar fashion, then it comes to automated drawing the cross sections. It comes to extracting the cross sections from any elevation source. In HEC-RAS, you can only extract the cross section from the terrain surfaces. You cannot extract the cross section from tin surface. You cannot extract the cross section from contours. You cannot extract the cross sections from land XML. Here you can do that from any kind of data. Now in Geo-HECRAS, we can import any kind of data. You can import your CAD drawings, you can import your land XML data, you can import your elevation grids, you can import your LiDAR point clouds, you can import your point data. In HEC-RAS, you cannot do that. And other than that, we have the combined license technologies from Autocad Civil, 3D MicroStation, Bentley, and SDGIS. In HEC-RAS, you do not get that. So these are the two of the differences that you would notice, you might have already noticed, but as you came up with the question, so I would like to clear that by saying these two things. Other than that, there is 2D modeling as well, where you will get to see a lot of differences if you have tried your hands on using the 2D part of the HEC-RAS.
Okay, because we have only 10 minutes left, so I will make it quick. From Elizabeth, can it be used to modeling a dam?
Yeah, absolutely.
And how to input the elevation data so it can be reliable to real condition? Should we take it from the third party? She means the data. Should it be taken from the third party or just internet?
The elevation data it's available in Geo-HECRAS online elevation data, but that is not so precise. For example, if I open up a new project here, add a base map image and add one of the coordinate reference systems from Indonesia. Let's say I select one of those right there, or let's say this one, and click on apply to map view. Now this will add a map of Indonesia here. If we zoom into a particular location where we have the river, let's say over here, there seems to be a river. You can right click and choose add elevation layer. You can choose download elevation DEM tab. You can save the elevation DEM. Let's call this one as DEM. And you can pick the limits for which you want to download the data. I'll go ahead and pick a small area over here and click on OK. Now it's downloading that elevation DEM. It's downloading about 165 titles. This DEM that will be downloaded, it will not be so precise to be used for the modeling. Mostly if you're doing the 2D modeling, then it needs a high accuracy data of the order of like 1 meter to 5 meter. When you have a data accuracy up to 30 meters, that's not going to be so good. So in that case, what you can do is you can simply go ahead and get the survey data from the field. And if you're doing the dam break modeling, you need to have if you're doing the reservoir modeling using the story, you need to have the bathymetry of the pond or the reservoir. You need to have the bathymetry of the channel. In 1D models, it doesn't need high accuracy data. If you just have the cross section, you can simulate the dam break model just with the cross section. But for knowing the extent of the flooding or the inundation area, you will need the DEM as well, the digital elevation model. So in that case, I would prefer getting the data surveyed rather than using the online DEM that's available freely on our software. So as it downloads the DEM here, I will show you the accuracy of that DEM, and that is not going to be so good and to be used for the modeling here.
Okay. So
I will show you one of the models.
Okay.
I did that for I don't know if the client was from Philippines or somewhere. It was CES Incorporated, and for them I did a model where they wanted to do a dam break analysis. We did both a dam break analysis using 1D and the 2D modeling.
Okay. Okay, while waiting, this is a short question from Anonymous. Where we can get this software, and is there a manual book to operate this?
Well, you get the tutorials on our website. You get the knowledge-based articles on the website where you can learn the software. Other than that, training comes as a part of the package. So whenever you need any help, so that we will provide the trainings and we will help you learn the software. And you get the unlimited technical support 24 hours a day, Monday through Friday. We're available 24 hours. Whenever you require any help, you can reach out to us and we will help you out. Now you can see the DEM that has been downloaded here. This is the online DEM that's been downloaded from our software. The accuracy of this DEM is not so good. If you click on that 3-dot button, it says it's at an accuracy of around 30 feet. That will be about 15 meters. So, yeah, no, it's about 10 meters, 10-meter resolution. So even if you want to smooth this out, we have some tools for that. If you go to terrain menu, you can go to generate contours. When generating the contours, you can smooth the contours out. There's an option to smooth contours. And you can go with the terrain surface limits, define the interval for the major and the minor contours, and click on generate. Now there it generates the contours with smoothing them out wherever you have those stair-step geometry. And later on, you can again generate the terrain from the contours for major and the minor contours from the GIS data. You can go ahead and save it. Let's call it as green smooth. You can define the resolution here, click on generate. And if we turn off this one, turn off the contours and turn on the new terrain that's been generated from the contours and click on OK. Shit, resolution colorful. So you can see it has smoothed out. So you can kind of make it better by smoothing out the contours and then creating a terrain surface out of it. So this is the terrain that's been downloaded from the software. Other than that, there is one project that I wanted to show you where we did a dam break modeling for one of the clients here. they had a reservoir on the upstream.
There's nothing to see.
You don't see anything? It's coming up.
I don't
It's coming up. It's
Oh,
loading.
okay,
It's
okay.
loading. On the bottom, I just see the progress bar
Okay.
is loading the drawing file. So in this case, the client had the drawing file for the area where we define the upstream as a reservoir and the
Oh,
downstream as a one-day reach, and there was a dam over here. If you double click
Yeah,
on
yeah.
that structure, there was a dam over here where they had a spillway around here, and this is the breach dimensions
okay.
or the breach parameters. So you can do all those kinds of models as well. And
Wow.
the same model was created for them where we did both 1D and the 2D modeling for the same project. Now, this was a 1D model, and then we did a 2D model, combined 1D, 2D. Where on the upstream, we have defined a reservoir with a storage area, and downstream is a 2D flow area. On the upstream, we define a lateral inflow hydrograph coming in from this reservoir, and on the downstream, we define the 2D flow area connected using the SA2D connection, which is the model as a dam. That way as well, you can do it.
Okay. So this software is really simplified the work to design them.
Yeah, absolutely, absolutely, very much.
How long it takes to modeling a dam?
Well, it depends on how big the model is. Like for this model, it took me half an hour.
Half an hour. Wow.
Yeah.
Wow.
Yeah.
It is really short.
Yeah.
Okay. The last question, Hank. Can we use this software to do modeling of river condition prediction for future? Maybe Baska means, can we use this software to look at the river
Certainly.
model for 10 years later, 20 years later?
You mean if the river is river morphology is changing, right? River is changing the direction. Yeah, absolutely. Like the thing is that we have not included the river morphology directly into the software. That is because it would have been same that of HEC-RAS. The only thing is that the most of the time any modeler spends is while he does the pre-processing, like creating the geometry. That's where most of the time is consumed. You have to prepare the geometry, you have to prepare the terrain data and all such things. Once you have done that, like here I have created my model, then I can right click and choose open in HEC-RAS. It will open the same project in HEC-RAS, and in HEC-RAS you just need to use two tabs there. You just need to define your costly unsteady flow data and the sediment data, and then run the analysis. That's the only thing that you need to do. All right.
Okay.
And there is
Okay,
one
so-
good question. There is one good question from Francisco. He's saying that can we use this to simulate using the rainfall? Yeah, absolutely. For the 2D models and even the 1D models with 6.0, you can directly apply the rainfall on your 2D flow area. It can be
Okay.
spatially varying or it can be constant, doesn't matter. If I go to unsteady flow data here, I can simply, or if I go to SA2D flow areas, I can assign the precipitation hydrograph. Click on that, define your precipitation in millimeters or inches, whatever the unit system that you're working with, and it will do the rain on grid model. Rain on grid models are very typical. When you see the rain falling on the 2D flow area or the storage area or the cross section, that means each cell is getting wet, is receiving some amount of water. That means a number of cells that receive the water will account for the computational time. So in rain on grid models, each cell receives the water. That means it will take a lot of time to run the models. So those kind of models are very typical, but I have done such kind of models myself as well. If I show you one of the 2D models that I recently did for one of the projects, one of the prospects here, that was for Pinoni Associates. And if I open up that model, they had a watershed for which they had the hydrograph, or we call it rainfall precipitation data. This is the 2D flow area, and this is the terrain data that are available right there. Now, this is a complete watershed. So now this is a complete watershed, On the downstream of that watershed, you just need to define a boundary condition and model that as and define that as normal depth. As an inflow,
I'm sorry, there is a noise here.
okay.
Where this? Okay.
All right. So this is a watershed, and for that, the client provided. If I go to unsteady flow data, client provides the precipitation hydrogram. If I click on that define button, this is our hydrogram. And you do not need to define the upstream boundary condition as your flow hydrogram or the runoff. You can simply apply the rain on the top of that, falling on that 2D mesh or the 2D flow area, and then you can simulate those kind of models as well. In this case, it doesn't have any results, so I could have shown you the results as well. So that way you can use the rainfall as well directly into, like with using the rain on grid model, it has kind of blurred the lines between hydraulics and hydrology. And with the 2D models being out there, that has become a trend. It has really speeded up the hydraulic modeling work. 2D models are comparatively easier to set up and even faster, and it has less stability issues.
Okay.
Yeah. And other than that, guys, I would recommend you to go through our website. We have some tutorials there as well for the bridge modeling, and there are some common workflow videos, and there are some detailed videos for like 1.5 hour or half hour. You can go through those videos as well. I will grab this link and provide that to you in the chat box. And whenever you get some time, go through those videos. And even if after that you have any questions, feel free to reach out to us. We'll be more than happy to help you out.
Okay, thank you, Mr. Hank Miller and the audience. So now I will close this session, and thank you very much for your attention and for attending this webinar. Hope we can see each other in another webinar again. And don't forget to fill the presentation form atau formulir absen untuk kelengkapan administrasi teman-teman. Thank you very much, and good afternoon from Indonesia, Mr. Hank Miller. Thank you very much.
Thank you very much. So if you can just allow me a moment, I will grab
Patrick.
I will grab Patrick on the call with us, and he will take it up from here. So just allow me a moment, okay?
Yes, please. Yes, please.
Thank you, everyone. We had about 150 people joining in here, and I really appreciate your time and patience. It was wonderful having you. So hope to see you guys soon using our software. Thank you, and just allow me a moment here.
Thank you.
Just allow us a few moments, and you will be joining in shortly, okay?
Okay.
Thank you.
Thank you, Mr. Hank.
Itu absennya di mana ya?
This is for some of the people who were asking for the license on the trial and the cost and all such things. So for that, I would not be the right person. So I would appreciate if you guys can wait for a few minutes. I will have Patrick join on the call, and he will explain you different licensing and the pricing options and what are the other services that we provide along with the license. Okay.
Okay. So we wait for Mr. Patrick Kelly, right?
Yeah. He will be joining in shortly in a few minutes.
Okay.
Jadi memang belum ada absennya ya?
Bagaimana?
Absennya memang belum ada. Link absen.
Sudah.
Ada di mana ya?
Akan taruh di komen, mungkin tertutup. Wait. Ini. Ini mohon menunggu sebentar. karena ada informasi follow up mengenai license software dari Patrick Kelly. Mungkin yang tidak ada pertanyaan atau live feedback bisa mematikan mikrofon dulu sebentar.
Hi Hank, can you hear me?
Yeah, Hank.
Hi Hank. Okay. Hi everyone. So how was the training with Hank today?
It is really good. It is really good, and it
Right. So do you
provides
guys?
much information that new for me, Mr. Patrick,
Okay.
right?
Okay. Yes, this is Patrick. Well, I understand. So do you guys see the benefits of using this program there?
Yeah, sure. It makes the job easier to make some modeling. Uh, I was surprised because for modeling a dam, I usually need 2 or 3 days, but with this software, it only takes an half and an hour for that.
Yes,
Wow.
right. So there are like 30 to 40 people just joined in here. I'm not sure from which organization they are, right? And I don't have the details. I'm sure you have the details for all the people, right?
Right.
So is there anyone who would be interested in this license there? Do you guys have any questions? You can just type in the chat box.
Okay, maybe Mr. Patrick, I will deliver your question in Indonesian because the most
Okay,
of the
all right.
audience is Indonesian. Oke, jadi teman-teman, Patrick mengatakan bahwa apakah ada teman-teman di sini yang ingin bertanya soal license product untuk bisa mengaktifkan full version, itu bisa ditanyakan ke kolom chat untuk dibahas.
Itu tadi sudah ada yang tanya, Pak. Di Rahmat Yusuf itu, Muhammad Sidas itu.
Oh begitu.
Ya, di jam 13.54.
Kayaknya ketutupan, yes.
di jam 13.54.
Well, I would like to ask whether there's a free software to learn first. I mean, for certain period. Thank you.
Maybe you can deliver the question again, Mr. Parwijanto.
Well, because I just late to come to the webinar. I just want to know whether I can have a free software to learn this software yang we are representing, yang just you are presenting this.
Okay, so Patrick, Mr. Parwijanto asked if there any free trial for the software so he can learn about it.
No, so we do not have any trial version or demo version which I can provide you. So let me tell you about the services. So we do have like two type of licensing options. One is floating network license, another is standalone workstation license. So in floating network license, any engineer can start using it as long as they are connected to the network. The network license will be installed on the network, and then you can install it on as many as computer systems you want. And any engineer can start using it from your own computer machine, but one at a time if you have one license. If you have 2 or 3 licenses, then 2 or 3 people can work at the same time. It depends on the number of licenses which you have. And another benefit with the network license is that we have unlimited check-in and check-out options. If you're going outside on a business trip, on a client meeting, and if you want to take the license with you, you can check out the license from your server, install it on your laptop, and you can take it anywhere outside the office for a week, for 2 weeks, and maximum for a month. And once you're back in, you can check in the license back again to the server. So that's how network license works. We also have a standalone workstation license, which allows you to install it on individual computer, and one single individual person can use it at a time. It can be logged to that machine.
Okay.
And along with the license, we will provide you some additional services as well. Like we will provide you free technical support with our engineers who are using the software day in and out. That means if you're working on a project, if you face any problem, just send us an email. Our engineers will be there to help you guys out. So we provide free technical support, and we will provide you regular updates of the software. And along with the regular updates, we will provide you onboard training, which means you do not need to worry about learning the software because we will provide you complete training. We have the complete training, schedule, which we can just provide to our clients once they purchase the software. So we will provide you complete training along with the certification so that, once we will just train you, we will just provide you a certification that you're professionally trained on the software. Also, once you start working on the projects, I will assign one of my engineers to you who will start working with you on your first couple of projects to reduce your learning curve and to train you on the software.
Okay, I will deliver your information in Indonesian. Jadi di sini ada tiga license. Yang pertama license bisnis, itu bisa dibeli dan diaktifkan untuk banyak komputer sekaligus. Nah, untuk license bisnis ini memiliki harga yang cukup di atas, lebih dari license network atau license internet dan juga license standalone. Yang kedua untuk license internet, itu teman-teman bisa memakai software berbasis internet, jadi tidak perlu mendownload, memakainya langsung dari internet juga bisa. Dan itu ada pembaruan license untuk per 1 bulan. Berikutnya ada standalone license di mana teman-teman hanya bisa memakai satu komputer atau satu IP atau satu key machine untuk satu komputer aja dan tidak bisa dipindah-pindah ke komputer lain. Dan setelah teman-teman beli, teman-teman bisa memakai software itu untuk pekerjaan atau bisa juga untuk pengajaran. Nah, dari 3 license ini semuanya ada service lain yang bisa didapat. Servisnya adalah kursus yang sudah termasuk dalam packaging license tersebut, dan ketika teman-teman sudah menyelesaikan kursus, teman-teman akan mendapatkan sertifikat profesional pengelolaan software ini yang bisa teman-teman pakai untuk pekerjaan atau sesuatu yang berhubungan dengan pekerjaan. Mr. Patrick, Do we have to
Yes.
buy the license again after 1 year or after a certain period?
No, so in initial purchase, we provide 13 months of free subscription, which includes free technical support, regular updates of the software, and free training along with the certification. After the first 13 months, we charge 20% of the software price just to renew the software for another year. However, we do have the license for 1 year, 3 year, and 5 year.
Oh, oke. Jadi untuk pembelian pertama itu ada 13 bulan masa berlaku, di mana dari 13 bulan tersebut teman-teman bisa mendapatkan full service berupa pengajaran, tutorial, dan juga pelatihan. Dan setelah 13 bulan, teman-teman akan mendapatkan charge untuk memperpanjang license tersebut 20% dari harga semula, yang bisa berlaku untuk 1 tahun, 3 tahun, atau 5 tahun. Seperti itu. So, there is any question in chat box from Sarmulia Sinaga? Is it an application program? If so, what is it called and how to get it? Is there no student version? Is there a manual? Oh, this question is already been answered by Hank. Yeah, you can see it in the link that Hank has been provided in chat box. For those who are unable to access the link, please use this link to watch the recorded session. Okay.
Jadi berapa Pak bayarnya Pak?
Oh, untuk harga pricing itu bisa dilihat di website civilja.com, lalu di bagian pricing. Patrick, is there any information about the pricing?
Yes.
For each license?
Yes. So just give me a moment. Let me just provide you the information.
Oke. Tunggu sebentar ya Pak.
Okay, so as I mentioned to you, so in this webinar, I believe all the people are from universities, right?
Right.
Or is there anyone from private consultant as well?
I am from consultant. I'm not from the agri.
Could you please write in your details there in the chat box because I'm not understand with whom I'm talking there.
Mr. Parwijanto mungkin bisa menulis nama dan juga pekerjaan, bisa ditaruh from university.
Along with your company details.
Yes.
Saya sedang ngetik nih.
Oke.
Are you a private consultant or are you working with any company?
Most of the time, I'm the owner, but the little one, you see, I think all the process is too high for us in Indonesia. Maybe it's only for big company, I think. But what I do is just curiosity to understand what you are presenting just now.
So could you please provide me your number as well, cell phone number?
Can you read it now?
Yeah. The phone number is from Indonesia, so The code is
Oh,
+62.
Yeah, I got it.
I
I
just
got it.
forgot.
I mentioned about the licensing options. By mistake, I just mentioned the a different person name.
Okay.
Yeah, so you can just read it out that we have like two type of licensing options: floating network license, standalone workstation license.
Is this information about pricing can be found on civilgeo.com
Now I'm
or
providing you the. Now I'm just sharing the pricing with you guys.
okay.
Biasanya tuh mahal, Pak. Enggak. Kalau kita
So
yang
here is the
kecil
pricing
gini kan,
information here. You can just see
kemarin
the chat box.
Okay. It is for first purchase, right?
That is one-time investment. That's it. You do not need to just invest the same amount. Okay.
Oh,
After that, you just need to maintain the license. That's it.
Oke. Jadi untuk harga ini cuma satu kali pembelian dan berlaku seumur hidup. Bukan seperti yang 13 bulan tadi.
yang $5.995 itu, Pak.
Sama yang 7.500 ini.
Itu mah penghasilan setahun juga.
Oke.
Belum bisa. Emang
Oke.
ini begini tapi jadi mahal-mahal. Oke, cuma nambah ini aja wawasan.
Oke.
Tapi kalau untuk yang buat kita karya itu bisa.
Apakah informasi ini sudah cukup, Pak Parwijanto?
Cukup, Pak, cukup.
Okay.
Terima
So
kasih.
Patrick, Mr. Parwijanto said the information is enough for him.
Okay.
Okay,
I understand.
so
Also, let me just tell you one more thing, that we do provide some special discount to the universities, institutes, and to private consultants who are just working all alone. Okay, so I'm sharing that was the general pricing which I shared with you guys. Now I'm sharing with you the university prices. Okay,
we are waiting.
so here are the university prices.
Is there any contact that we can use to reach you by email or by your social media, maybe?
Okay, so here is my email address, patrick.kelly@civilgeo.com. You guys can just reach out to me through email. Okay, so I shared the general information with you guys. If anyone is interested in purchasing the license, or if any one of you are facing the budget problem, money problem, or anything such like that, please write me in the email, share it with me that you guys are interested, and if you're facing any problem, just let me know. I will help you out.
Okay, I will deliver this information in Indonesia, Kelly. So, jadi harga ini merupakan harga yang sebenarnya masih bisa dinego kepada Kelly apabila teman-teman berminat untuk masing-masing license ini, tetapi merasa bahwa harganya terlalu tinggi, teman-teman bisa langsung hubungi Patrick melalui email untuk berbicara lebih lanjut mengenai pricing ini. Okay, Kelly?
Yeah.
I think there is no further question from the audience. Is there any information you want to sharing again?
So I shared my email address. If anyone is interested, they can just let me know. They can just send me an email. I will be active on the emails. Once I'll receive the email, I instantly just call them. I would also suggest them to just write down their number as well, because once I receive the email, I will directly call them to discuss further.
Oh, okay. Maybe you can find the database on the form that we already provide for you guys.
Please repeat once again.
Maybe you can see the audience background on the form that we already provide for you guys. Maybe for next 1 or 2 hours we will share the form to you.
Sure, you can just share the form with me because I'm not able to just see the details. I can see the only just a blank form, which anyone can just fill.
Okay. So we will send it by email.
Sure, no problem. So,
Okay.
does anyone has any questions?
Oke, apakah ada pertanyaan lanjutan?
Ini ke Bapak ya, kalau ini mengeluarkan sertifikat untuk ikut webinar nggak nih Pak?
Oh ya, sertifikat akan langsung dikirim ke email masing-masing sesuai dengan yang sudah diisi lewat form, Pak.
Oh ya, ya udah.
Nanti akan langsung, ya sama-sama. Nanti akan langsung dikirim.
Iya. Memang webinarnya banyak software yang bermunculan. Biasanya tuh secara finansial rata-rata nggak terjangkau. Soalnya untuk menutup biaya itu bisa.
Okay, thank you, Pak Parwijanto. So there is no further question for you, Hank and Patrick. So I think the session is enough. Thank you very much for your information, and we will keep in touch by email.
Sure. So you guys have my email address. I provided you guys my email address there in the chat box. You guys can just reach out to me anytime whenever you have any questions. Okay.
Okay. Thank you, Patrick. Thank you, Mr. Hank. And good afternoon from Indonesia. Thank you very much. So the audience may leave the room. Thank you very much.
Thank you, everyone. Thank you so much for attending the training webinar today.
Okay.